So now we are going to discuss about analysis of a perfect frame or a truss. Let us discuss first introduction, then we will move to the problems. A structure made up of several bars or members riveted or welded together is known as a frame. The support reactions at two ends of a frame may be found out by the same principles as those for a beams, what we discussed in the previous videos. And so we can solve this analysis by two methods. One is analytical method, another one is graphical method, right? And types of frames is divided into two categories. One is perfect frame, another one is imperfect frame, right? So the example for perfect frame, which is a triangle, that we will discuss later, that we will discuss in our next slide. Perfect and imperfect, right? So what is the perfect frame? When LHS which is equal to RHS, then it is a perfect frame, right? Then other two cases, which is imperfect frame, which means the degree of freedom which is equal to 0, right? Deficient and redundant, right? So equation which is equal to n which is equal to 2j minus 3. This is the equation. So equation n which is equal to 2j minus 3. So n which is equal to number of member and j which is equal to number of joints. So based on this equation, this is LHS and this is RHS, right? So LHS which is equal to RHS, then which is a perfect frame. If the LHS is less than RHS, then it is a deficient frame. And if LHS which is greater than RHS, then it's a redundant frame. So let us discuss an example for this case. So this is a simple pictures for the trusses and how the loads are acting on the trusses. And this is the major equation, n which is equal to 2j minus 3. Substitute the values in this. So n which is equal to 3. So link 1, link 2 and link 3. So 3 joints are there: joint 1, joint 2, joint 3, A, B, C, right? Link 1 and link 2 joining at A, link 2, link 3 joining at B, and link 3, link 1 joining at C point. So substitute these values, 3 links. So 3 into number of joints 3 minus 3. So 3 which is equal to 6 minus 3. So 6 which is 3 which is equal to 3. So LHS which is equal to RHS. That's why this is a perfect frame, right? This is a perfect frame. And next one, which is 4 links are there: link 1, link 2, link 3 and link 4. So n which is equal to 4. How many joints? At point A, link 1 and 2. At point B, 2 and 3 is joining. At point C, 3, 4, and point D, 1, 4, right? So j which is equal to 4, right? Substitute the value, 4 which is equal to 2 into 4 minus 3. So 4 which is equal to 8 minus 3. So 4 which is equal to 5, right? So 4 is less than 5. So 4 is less than 5. LHS equal to RHS. So this is a deficient frame, right? Deficient frame. And similarly here, number of links 1, 2, 3, 4, 5, 6 links are there. So n which is equal to 6. Number of joints 1, 2, 3, 4, right? So j which is equal to 4. Substitute the values in this equation. So n which is equal to n which is equal to 6, which is equal to 2 into 4 minus 3. So 6 which is equal to 8 minus 3. So 6 which is equal to 5. 6 is greater than 5, right? So LHS is greater than RHS, then this is the redundant frame, right? So now assumptions. What are the assumptions made in finding out the forces in a frame or truss? So 3 assumptions. First one is the frame is a perfect frame and the frame carried a load at the joints and all the members are pin joined, right? So this reactions of supports of the frames. So 3 supports are there: only simply supported, roller support and hinged supports, right? So already we discussed simply supports has only one vertical reaction and roller support has only one vertical reaction which is perpendicular to the roller base, and the hinged support has 2 reactions, horizontal and vertical, right? So this is a roller support and this is a simply supported beam. It has only one vertical, and this is also a vertical which is perpendicular to the base, right. And here this is a hinged support. See the difference between the simply supported and hinged support. Here there is no pin, whereas here see this point a pin is there. So that's why this is a pin support. So two reaction forces are there, one is horizontal, another one is vertical. And the nature of forces in members, so totally two forces are there, one is horizontal forces, one is tensile, another one is compressive forces, right. So body pushed inward by two equal and opposite forces, that is called as compressive forces, and if the body pulled out by two equal and opposite forces, then it is a tensile forces. Only two forces acting on the members, one is tensile, another one is compressive, right. So this is a simply supported beam, and this is the simply supported beam. So we mention in different way, one is this, another one is this. This is the representation of simply supported beam, right. There is no pins, whereas here see in this area, so two pins are there, whereas in this case there is no pins. So this is a simply supported beam, and this is also a simply supported beam, whereas in this case this is the pin joint, and see here a pin is there, that's why this is a pin joint, right. And this is the roller joint, because rollers are there, right. So in this case only one vertical which is perpendicular to the roller, whereas the pin joint one is vertical, another one is horizontal, whereas for simply supported beam only vertical forces are there, right. So let us solve a simple problem. This is the picture, a framed structure of 4 meter span and 1.5 meter height subjected to 2 point loads at B and D. So B at point load which is acting horizontally, and at point D the vertical force is acting 12 kilonewton is acting downward. Find the reactions at A and C. So see the picture at A, the pin joint is there. See in this area two pins are there. So this is a pin joint and this is the roller joint. As we discussed, pin joint is having two reaction force, one is vertical force, another one is horizontal force, right. So this is horizontal A x and this is vertical A y, right. So this is a roller support, has only one support which is a vertical, which is perpendicular to the base, right. So this is R C, this is R A y, this is R A x, horizontal reaction force and horizontal vertical vertical reaction forces, and this is R C, right. Now we know that horizontal forces which is equal to vertical forces. We have to frame the equation. So what is the finding? Finding which is equal to R A x R A y. With the help of this we can find R A and R C, right. So first we have to frame the equation. Upward force which is equal to downward force. So two upward forces are there, one is R A y and R C. So R A y plus R C which is equal to, what is the downward force which is equal to 12 kilonewton. 12 kilonewton. This is equation 1, right. So what about horizontal forces? Horizontal forces R A x which is equal to 8 kilonewton. So R A x which is 8 kilonewton, let us assume in this direction R A x, okay. So R A x which is equal to 8 kilonewton. If suppose we assumed R A x in this direction, then both are same, then which comes R A x which is equal to minus 8. So instead of removing minus, we have to assume this direction. So R A x which is equal to 8 kilonewton in this direction, right. This is the direction, right. So now we have to take moment. So now take moment about O, take moment about any point A or B. Now we are going to take moment about A, right. So clockwise direction which is equal to anti-clockwise direction. So R C into perpendicular distance 4 meter. So R C which is anti-clockwise direction. So R C into 4 meter which is equal to, both are clockwise direction, 12 Newton, 12 kilonewton and 8 kilonewton, right. So 8 into what is the perpendicular distance? 1.5 meter, right. So 1.5 plus 12 into 2. 12 into this is 2 meter, which is perpendicular with respect to point A, right. So, RC, which is equal to 8.15, 8 into 1.5. So, 8 into 1.5, which is equal to 12 plus 12 2s are 24 divided by 4, right. 12 plus 24, which is equal to what is the value? 12 plus 24, 36. So, 36 divided by 4, 36 divided by 4, which is equal to 9 kilonewton. This is 9 kilonewton, RC, which is equal to 9 kilonewton, right. Then RAY, which is equal to 9. So, 12 minus 9, which is equal to 3 kilo, 12 minus 9, which is equal to 3 kilonewton, right, upward. Yes, HA, which is equal to 8 kilonewton, that is RAX. Then VAX, which is equal to 3 kilonewton, that is RAY, right. Then last one RA, which is equal to 8.54, right. So, if you want to calculate RA, what is the formula? RA, which is equal to root of RAX square plus RAY square, right. So, substitute in this value RAX, which is equal to what is the value? 8 kilonewton squared plus this is 3 kilonewton squared, right. So, which is equal to what is the value? Root of 64 plus 9, right. So, take this root, which is equal to 8.54 kilonewton. So, 64 plus 9, what is the value? So, root of 64 plus 9, right. So, 64 plus 9, which is equal to 73. So, take root for 73, which is equal to 8.5 kilonewton, right. So, this is how you have to solve the problem. Okay. Thank you.